Carbon and its compounds. Carbon content. Basic features of carbon. Catenation versus tetravalency. Bonding of carbon. Allotropy of carbon. Allotropy. Diamond. Uses of diamond. Graphite. Uses of graphite. Fullerenes. Graphene. Hydrocarbons. Types of hydrocarbons. Saturated versus unsaturated hydrocarbons. Naming of hydrocarbons. Functional groups. Homologous series. Isomers. Trick to identify number of isomers. Organic compounds. Allopathic, aliphatic, acyclic versus cyclic compounds. Heterocyclic compounds. Aromatic compounds. Number of covalent bonds. Chemical properties of carbon compounds. Combustion, oxidation of alcohol to ethanoic acid, addition reaction, substitution reaction, vegetable oil versus animal fat, boiling point and solubility of hydrocarbons, important carbon compounds, methanol, ethanol, reaction of ethanol, reaction with sodium evolution of hydrogen gas, dehydration of ethanol, different types of alcohol, ethanoic acid, reaction with base, esterification reaction, soaps and detergent, saponification, detergents. Carbon content in earth crust 0.025%, in atmosphere 0.03%. Basic features of carbon. Catenation, tetravalency. Catenation, unique ability to form long CC bond. No other element exhibit catenation property. Reason, electronic configuration of carbon which contributes its ability to catenate. 6C 2 comma 4, C6 2 comma 4, 4 shares this electron. Carbon's small size makes it CC bonds stronger than other elements. Tetravalency, capability to form 4 bond with other atom of carbon or other monovalent elements. Carbon form strong and stable bond due to its small size. Covalent bonds are usually formed between nonmetals. Bonding of carbon. Oxygen has 6 electrons and requires 2 more electrons to complete its octet. Requires 4 more electrons to complete its octet. Okay. O double bond C double bond O gives CO2, and C individually with 4 H's, CH4. Covalent bond. Bonding form Bonding formed due to sharing of electrons. This is a weak bond. Boiling point and melting point will be weak. The carbon bond is called tetravalent because it forms 4 covalent bonds. The ends of each bond has 2 electrons. O2. Okay. Oxygen cannot form long chains of bonding like carbon because of its small size and high electronegativity, and because it lacks d orbitals. Allotropes of carbon. Allotropy. Allotropy is the property of some chemical elements to exist in two or more different forms in the same physical state, known as allotrophies of a known as allotrophies of the elements. Allotropes of carbon. Diamond, graphite, fullerenes. Diamond, 3D tetrahedral structure, bad conductor of electricity. sp3 hybridization. Each carbon atom is bonded to 4 other carbon atoms. Can be synthesized by subjecting pure carbon to very high temperature and pressure. Hardest natural substance known. Diamond and crystalline silicon. Diamond and crystalline silicon is isomorphous. Are isomorphous. High refractive index 2.42. This is a structure of diamond. Uses of diamond. Use for cutting glasses, for sharpening hard tools, manufacturing tungsten filament. Diamond is covalent, yet it has high melting point because It has a 3D network involving strong CC bonds that are difficult to break. Isomorphous. It means having similar shapes or crystalline structures. Graphite. 2D layer structure held by Van der Waals Van der Waal forces. Van der Waal force. sp2 hybridization. Hexagonal plane array. Each carbon atom is bonded. One electron is free. One of these bonds is a double bond to satisfy valency of carbon. Good conductor of heat and electricity. Most stable form of carbon. Graphite is soft and slippery because it has a layered structure weakly bonded together because of which they could slide over each other, and that is why mostly used in lubricants. Graphite structure. It is held together because of weak weak van der Waal weak van der Waals forces. Covalent bond. Carbon atoms. Van der Waals bonds distant 0.34 nanometer. Use of graphite in making electrodes. Use of pencil or lead as a dry lubricant, as moderator for fast moving neutron in atomic reactors. Fullerenes, as known as Buckminster fullerenes C60. Okay, use of graphite. Battery 25%, refractories 35%, lubricant 10%, foundry 7%, pencil 4%, others 19%. Fullerenes, also known as Buckminster fullerenes C60. Cage-like molecules. sp2 hybridization. Contains both single and double bond with other 3 carbon atoms. 12 pentagons plus 20 hexagonal rings. A hexagonal ring can be fused with a hexagonal or pentagonal ring, but a pentagonal ring can only be fused with hexagonal ring. Purest form of carbon. And fullerenes, very strong. Graphene. It is a single layer of carbon atoms arranged in hexagonal honeycomb lattice. Hydrocarbons. Hydrocarbons. Hydrocarbons are organic compounds that are extremely made up of only two kinds of atoms, carbon and hydrogen. Okay. Graphene, extremely thin and strong. Acetylene is used in welding of metals. Types of hydrocarbons: unsaturated and saturated. Saturated, single bond between carbon atoms, are alkaline or paraffins. Example, ethane, single bond. Unsaturated, more than one bond between carbon atoms. Alkenes or olefins. Example, ethene, double bonded. Plays an important role in fruit ripening. Alkynes. Example, ethine, triple bond. Saturated hydrocarbons. CnH2n plus 2. Alkanes. Alk, alkanes. Alkane. General formula. Butane. Surname is ane. And unsaturated hydrocarbons. CnH2n. CnH2n. Alkenes. Ending with ene. Ethene. CnH2n minus 2. Alkyne. Ending with ine. Propine. Name of hydrocarbons: 1 meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 dec, 11 undecane, 12 dodecane, 13 tridecane, 14 tetradecane, 15 pentadecane, 16 hexadecane, 17 heptadecane, 18 octadecane, 19 nonadecane, 20 isocene. Prefix added before name. C3H2CH3. Condensed structure propane. C3H6 propane. Bond line structure of propane. CH3 CH2 CH3. IUPAC. International Union of Pure and Applied Chemistry is responsible for naming the hydrocarbons. Two types of books: Blue Book, Red Book. Blue Book for naming of organic compounds, Red Book for naming of inorganic compounds. CH3, C, triple bond C, CH2, CH3. Nearest position of double bond or triple functional groups. Pent 2 ion, pent 2 ion, and CH3, CH2, CH2, C triple bond CH, pentyne, and CH1, CH, and CH3, CH2, CH3, CH3 alkali group, and CH3 looks for continuous long chain, look for continuous long chain, that is 2 methyl butane. Root, longest continuous chain of a compound. CH3 methyl, CH2 CH3 ethyl, CH3 CH2 CH3 propyl, and 3 methyl pentane, CH3 CH2 CH, CH3, and upside C, CH2 CH3, 3 methyl pentane, and CH3 CH2 CH, CH3, C triple bond CH, 3 methyl pentane, pentyne. Class of compound, functional group, suffix used, common formula, examples: alcohol OH, OL, ROH, ethanol, CH3 CH2OH, functional group ethanol, aldehyde, carbon double bond OH, AL, RCHO, acetaldehyde, CH3COH, functional group ethanol, and ketone, C double bond O, one, RCOR, acetone, CH3 COCH3, propane, CH3 C double bond O CH3, carboxylic acid, C double bond O COH, oic, RCOOH, acetic acid, and acetic acid, CH3 COOH, ethanoic, ester, C double bond O OR, O8, RCOOR, methyl acetate, CH3 COOCH3, COOR, ether, OR, ROR, dimethyl ether, prefix used here, CH3OCH3. For halogen as functional group, for halogens as functional groups, prefix is used. Homologous series consists of one functional group which decides the property of carbon compounds regardless of length of carbon chain, differs by CH2 unit and mass by 14 units. Chemical properties remain same. As the molecular mass increases, melting point and boiling point increases. Homologous series: alkanes, alkynes, alcohols. Alkanes: CH4, C2H6, C3H8, C4H10, CH2, 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 and alkynes: CH2, C3H4, C4H6, C5H8, CH2, 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 and alcohols: CH3OH, C2H5OH, C3H7OH, C4H9OH, CH2, 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 CH2. Isomers: they have same chemical formula but different structure. Example: CH3, CH2, CH2, CH3, C4H10 butane, and CH3, CH, CH3, CH3, C4H10 2 methyl propane, and CH3, CH2, 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 CH3 pentane 2 5 minus 4 plus 1 is equal to 3, and CH3, CH, CH3, CH2, CH3 2 methyl butane, and C, CH3, 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 CH3 2 comma 2 dimethyl propane. Trick for identifying number of isomers. 2 power n minus 4 plus 1. 2 power 4 minus 4 plus 1. 2 power 0 plus 1. 2. Single bond made of 1 sigma bond. Double bond made of 1 sigma bond and 1 pi bond. Triple bond made of 1 sigma and 2 pi bonds. Isomers in hexane. 2 power 6 minus 4 plus 1. 2 power 2 plus 1 is equal to 5. Heptane. 2 power 7 minus 4 plus 1 is equal to 2 power 3 plus 1, that is equal to 9. Octane. 2 power 8 minus 4 plus 1, that is equal to 2 power 4 plus 1, equal to 16 plus 1 plus 1, 18. Nonane. 2 power 9 minus 4 plus 1 equal to 2 power 5 plus 1, that is equal to 32 plus 1 plus 2 equal to 35. Organic compounds. Allopathic or acyclic and cyclic. Allopathic and acyclic open chain compounds. Alkane, alkene, alkyne. Methane, CH4. Propane, C3, C3H8. Cyclic, closed chain or ring compounds. Benzene, C6, C6H6. And naphthalene, C10H8. And cyclopropane, CH2, CH2, CH2. Cyclic formulas. Alkane, CnH2n. Alkene, CnH2n minus 2. And alkyne, CnH2n minus 4. Heterocyclic compounds. They are cyclic compounds that have atoms of at least two different elements in their ring structure. Important. Furan, oxygen, and thiophene, S, sulfur. Pyrrole, hydrogen and nitrogen. Pyridine, nitrogen. Mm, Pyrimidine, two nitrogens. Imidazole, nitrogen, nitrogen and hydrogen. Oxidizole, nitrogen, nitrogen and oxygen. Isozaloli, oxygen and nitrogen. Oxazolol, oxygen and nitrogen. Imidazole, nitrogen, nitrogen, hydrogen. Pyrazole, nitrogen, nitrogen, nitrogen. Isothiazole, sulfur, nitrogen. Thiazole, sulfur, nitrogen. Pyrazine, nitrogen, nitrogen. Isoquinoline, nitrogen. Quinoline, nitrogen. Isoquinoline, two rings and nitrogen. Quinoline, two rings and nitrogen. Benzofuran, two rings and oxygen. Benzimidazole, nitrogen, nitrogen and hydrogen. Aromatic compounds. They are group of compounds that have a cyclic conjugated structure and contains 4n plus 2 pi electrons, making them particularly stable. Eric Haeckel's rule. Benzene, simple aromatic compound. Toluene, benzenoid aromatic compound. Benzene with CH3. Number of covalent bonds. C2, CH3, CH2, CH3. There are 10 bonds. And CH3, CH, CH2, CH3, 12 bonds. And here 18 bonds. And C6, 12 bonds. Chemical properties of carbon compounds. Combustion. Carbon in all its allotropic forms burn in oxygen to give carbon dioxide plus heat plus light. CH4 plus 2O2 on combustion gives CO2 plus 2H2O plus heat plus light. Combustion. CxHy plus O2 gives CO2 plus H2O plus heat. CO2 plus H2O. CO2 plus H2O. O2 O2. CxHx. Saturated hydrocarbons, unsaturated hydrocarbons. Saturated hydrocarbons gives clean blue flame. In limited supply of air gives sooty flame. Example, hexane, alcohol, butane. Unsaturated hydrocarbons gives yellow sooty flame. Example, camphor, anthracene, benzene. LPG gas contains butane and propane. Oxidation of alcohol to ethanoic acid. Ethanol, CH3CH2OH. And in presence of in potassium permanganate, H plus or KMNO4 or H plus and K2CrO7, that is potassium dichromate. Reaction is carried out in presence of a powerful oxidizing agent. Choose any one of two. Gives ethanoic acid, CH3, C double bond O and single bond OH. Addition reaction. Unsaturated hydrocarbons add hydrogen in presence of catalyst uh, nickel palladium to give saturated hydrocarbons. RCr, C double bond, C double bond C and CrCr gives in presence of nickel or palladium in hydrogen in presence of nickel or palladium gives RCHR and single bond CHR and R. Substitution reaction. CH4 methane natural gas plus Cl2 in presence of sunlight gives CH3Cl chloromethane plus HCl. In presence of sunlight it gives CH2Cl2 plus HCl, and in presence of sunlight it forms CHCl3 chloroform plus HCl. In presence of sunlight it forms CCl4 plus HCl. Vegetable oil versus animal fat. Vegetable oil, long unsaturated carbon chains preferred for cooking. Animal fats, saturated fatty acids harmful for health. Vegetable unsaturated and animal fat saturated. Boiling point and solubility of hydrocarbons. Alkalines generally have slightly higher boiling point as the chain increase. Okay. Point compared to alkalines and alkanes. Alkenes more than alkane. Okay. This is due to increase in number of chains. And ethane less than propane less than butane, and propane as a number of carbon is in alkane increases, its boiling point increases significantly. Also, molecule with strong intermolecular forces will have high boiling points. Solubility of hydrocarbons. Solubility decreases as the length of hydrocarbon chain increases. C2H6 greater than C3H8 greater than C4H10. Important carbon compounds. Methanol, wood spirit, first extracted from wood spirit. Intake of methanol is very small quantities can cause death. Methanol, formaldehyde converts to formic acid in mitochondria. Methanol oxidizes to methanol in liver, coagulates protoplasma. Methanol also affects optic nerves, causing blindness. Ethanol, pleasant smelling. Active ingredients in alcoholic drinks. To prevent the misuse of ethanol produced for industry use, it is made unfit for drinking by additional methanol plus blue dye added for identification. This is called denatured alcohol. Good solvent used in medicine such as tincture of iodine, cough syrup, cough syrups, soluble in water in all proportion. Reaction of ethanol, reaction of sodium, evolution of hydrogen gas. Na plus C2H5OH gives Na plus C2H5O minus, sodium ethoxide plus H2 gas. Dehydration of ethanol. Heating ethanol at 443 Kelvin with excess concentrated sulfuric acid. Dehydrating agent. results in dehydration of ethanol to ethene, C2H5OH, and in presence of hot concentrated sulfuric acid gives C2 CH2 CH2 double bond CH2. Different types of alcohols. Primary alcohol, a OH attached to one carbon, and secondary alcohol, carbon is attached with two other carbons and one OH. Tertiary alcohol, carbon is attached to three carbons and one alcohol. Alkali group is also represented by R. Ethanoic acid, acetic acid, vinegar, 5 to 8% solution of acetic acid in water, used in preventing pickle. The melting point of pure ethanoic acid is 290 Kelvin, and hence it often freezes during the winters, called glacial acetic acid. Reaction with base, CH3COH plus NaOH gives CH3COONA plus H2O. Sodium benzoate, used as a preservative in many foods, medicines, and cosmetics. Esterification reaction, CH3COOH plus C2H5OH HOH, water forms, that is CH3C C11O CH2 plus H2O. C double bond O OH, OIC group, CH3 CH2 C double bond O OH, propanoic acid. Ester, formed by reaction of acid and alcohol. Sweet smelling substance used in making perfumes and flavoring agents. Soap and detergents. Sopanification reaction, used in preparation of soaps on treating ester with sodium hydroxide. The ester is converted back to alcohol and sodium salt of carboxylic acid, CH3COO C2H5. In presence of sodium hydroxide becomes CH3COONA plus C2H5OH. Sodium or potassium salts of long chain monocarboxylic acid forms palmistic acid, oxalic acid, stearic acid. Soap obtained remains in colloidal form. It is it is precipitated from solution by adding NaCl. The solution left after removing the soap contains glycerol recovered by fractional distillation. Cleansing action of soaps and detergents. Micelles structure, soap molecule, fabric, dirt. Micelle structure. Next to two, hydrophilic head. Okay, polar head pointing towards water, hydrophilic head. Non-polar tail pointing towards dirt, hydrophobic head, hydrophobic tail. And third, dirt-free fabric, dirt wrapped within soap micelle. Cleaning action of soap is due to formation of micelles. It forms emulsion in water and will not come together to precipitate because of ion-ion repulsion. Soap micelle shows Tyndall effect. Thus, soap solution appears cloudy. Soap doesn't work in hard water because in hard water it reacts to form calcium and magnesium salts, which is an insoluble substance called scum, and in it doesn't work in acidic condition because it forms insoluble long chain fatty acids. Detergents, sodium salt of sulfonic acid or ammonium salt with chloride bromide ions, work in both hard and soft water, dissolve in water faster than soap.